So this is an overview of things that you'll need to know before you go into learning calculus. You'll need to know trigonometry and have a really good understanding of your algebra. I would probably say that calculus is more algebra than anything else, which is pretty cool. You, for the longest time, haven't been given information as to what calculus is. It's like this crazy math with these weird symbols, and it's like a totally different language. But calculus is pretty much the study of change, and slopes are a really big thing in calculus. So you will need to know slopes. For example, this kind of stuff, where you have some function, and you have your delta x and your delta y, and that is your change in the y direction and your change in the x direction, or y2 minus y1, x2 minus x1. Yeah, you have to be familiar with this. Another thing you should be familiar with is the point slope form, which says y minus y1 is equal to m times the quantity of x minus x1, where y1 is what you plug in and x1 is what you plug in when you have those numbers. Again, m, your slope. Something that I want to point out here is that if you have a perpendicular line, some function like that, these are perpendicular because they create a 90-degree angle. When lines create 90-degree angles, their slopes are inverses of each other. One line will have an m equal to some, let's say, w, I don't know, and the other one will have a slope of negative w. Another quick thing about functions and their graphs, you should know how to be able to tell what the domain and the range of a function is. So if I gave you a function like, say, x squared plus 2y equals 1, like that, you should know just by looking at it, this function takes in all numbers from negative infinity to infinity for the x values. So your y could be anything from negative infinity to infinity. If you don't know how to tell what the domain and range function is, you should probably go ahead and look at some other videos talking about that kind of stuff. Another thing that you should know that would be great for calculus and being able to understand it very well is trigonometry. Trigonometry is the study of triangles, obviously, but there are some identities there that you need to know in order to be able to integrate things a lot easier. Sometimes things, it can be super hard if you don't use the trigonometric identity. So that is why it is definitely a useful thing to know. So we'll start with the basics that everyone knows, or should know, going into calculus. Alright, so we have our basic right triangle here, with the adjacent side, that's theta, that's a reference angle. So we got the adjacent side, we have the opposite side, and we have the hypotenuse in the right triangle. So sine of theta would be equal to the opposite over the hypotenuse. The cosine is equal to the adjacent over the hypotenuse, and the tangent is equal to the opposite over the adjacent. One way to remember these is something that you've probably heard, so Catilla. If you remember this stupid little phrase right here, you are good with the identities. Sine, opposite, hypotenuse. Ka is cosine adjacent hypotenuse. Toa is the tangent, which is equal to the opposite over the adjacent. Alright, now down to their inverse functions right over here. We got cosecant, secant, and cotangent. So the cofunctions are just the opposite of these guys up here. So if you look at the cosecant function over here, you see that it's hypotenuse over opposite, which is just the inverse of this. It's just flipped. Another way to write these guys, so right over here we have 1 over the sine of theta is equal to cosecant. It's just another way to write it. Sometimes it can be helpful for identifying different trigonometric identities. Speaking of which, we are now going to go to. Alright, So these are the three trigonometric identities that you should know, just kind of by heart, if you've been through trig. One of the major ones is this first one right here, where it says sine squared theta plus cosine squared theta is equal to 1. If you notice here, this squared is inside and this one is outside. Just note that those things mean the same thing. These two right here are kind of derived from this one up here. If you don't know how to get to these two, but you know this one by heart, well then you're pretty set. For this one, you take this original equation and then divide everything by cosine to get this one. For this bottom one right here, you divide by sine to get that one, and I will show you real quick. So here we have our trig function, and then we'll divide by cosine of everything. Sine over cosine is tangent, and they're squared, so we get tangent squared theta plus anything divided by itself is 1. And over here we have 1 over cosine squared, which is secant squared theta. And thus our new trigonometric identity. Alright, here's another one of our trigonometric identities, where it says the sine of theta plus some phi, or phi, is equal to the sine of theta times the cosine of phi, plus or minus the cosine of theta times sine of phi. Now those you might just have to remember, by heart, or some kind of rigid repetition. In all honesty, once you get into higher level maths, depending on your professor, they might let you bring in what's called a cheat sheet, which you bring in so you don't have to force yourself to remember all these identities and stuff. I think they're really stupid to remember when you can just look them up. When you're going into after your PhD and stuff, and you're doing research, you're not going to remember every single thing that you've ever learned, like say this trigonometric identity. So you'll know when to use it. You just will have to Google it, and that's life. So rant over. I want to show you guys a cool identity that pops out of this one right here, and that is the sine of 2 theta, but we don't know the identity for that. Well, we kind of do. It's this one up here. So yeah, sine of theta plus theta. It looks like this one. We're just going to replace phi with theta instead, and plug it into this right here. So we plug in sine of theta, cosine theta, plus cosine theta times sine of theta, and we get 2 sine of theta cosine of theta, because if you move this sine over here and move that cosine over there, you get exactly the same thing as you get right here, and thus leading us to this identity right here, which is the sine of 2 theta. So we got our cosine of theta plus our phi, which is equal to cosine phi times cosine theta, and then plus or minus plus sine of phi times sine of theta. I like to write it down like this so that you know that it's cosine sine, cosine sine. Alright, this is another one that you'll need to remember. We have the tangent of theta plus or minus phi, or phi, and that is equal to this monstrosity over here. I'm pretty sure that is derived by the sine of theta plus phi over the cosine of theta plus phi. So if you don't remember this one, but remember these two, then you'll have to do some algebra to work it out. But in the long run, it's probably a little easier to do than remembering this. Alright, so I won't teach you the double angle formulas because they are derived by the identities that we just used, where we had sine, cosine, or tangent of theta plus or minus our phi. Just what you would have to do is plug in theta twice, and then you would get that double angle formula. Alright, this is the law of cosines. It can be written in different ways depending on what the angle is, but I'm just going to give you one example of the law of cosines, because these are things that you should already know, which says a squared is equal to b squared plus c squared minus 2bc cosine of a, where a is this angle right here. And this is typically used for when you know two of the sides, the lengths of the sides, and you have an angle. It'll give you the third side. It can be used for other things as well. Say that you have three sides, but you don't have an angle and you would like to know that angle, then you can plug it in here. If you know side A, side B, and side C, you solve for A and get your angle. You should probably also know how to evaluate some of these trigonometric functions. And when I say that, I mean like if I gave you the sine of pi over 2, would you know that that was 1? Or, cosine of 0, those kinds of things. Alright, that is all for my overview of the stuff that you will need pre-calculus. That's its own course, but I never took it, so God knows what I'm missing. But yeah, that is my pre-calculus overview of the stuff that you need to learn before you do the actual calculus. If you guys like this video, please give it a like. Subscribe if you're into math stuff. My favorite math YouTuber is Papa Flammy, or Flammable Maths, as he's called in the YouTube world. You should definitely check him out because I know I do. Alright, see ya.